The year is 1939. At a restricted dock in Japan, a massive, unmarked crane begins to hoist a series of colossal wooden crates from the hold of a freighter. To any passing observer, it looks like industrial machinery, but inside these crates lies a Trojan horse, a masterpiece of American engineering that the Imperial Japanese Navy believes will give them the power to strike the United States from across the ocean. They had just spent an astronomical sum, equivalent to millions in today's currency, to acquire a single aircraft, the Douglas DC-4E. To the Japanese, this wasn't just a plane, it was a blueprint for a monster. But they were about to learn a bitter lesson in aviation. Sometimes, the most expensive secrets are the ones your enemy is happy to let you steal. To understand why Japan was so desperate for this aircraft, we have to look at the state of the world in the late 1930s. The golden age of aviation was in full swing, but it was a period defined by a brutal reality: distance. For a nation like Japan, an island empire with ambitions of dominating the Pacific, distance was the ultimate enemy. They needed a king of the skies, a heavy, long-range bomber that could carry massive payloads across thousands of miles of open ocean. The problem? Japan didn't know how to build one. Their expertise was in agile, lightweight fighters like the Zero. When it came to four-engine giants, they were decades behind. Meanwhile, across the Pacific, the Americans were having their own problems. In 1935, United Airlines had approached the Douglas Aircraft Company with a proposal that sounded like science fiction. They wanted a super airliner. They wanted a plane that could carry 42 passengers in luxury, featuring sleeping berths, a private dressing room, and even a kitchen. It was to be the largest and most advanced passenger plane in the world. This project became the DC-4E, the E standing for experimental. It was a technological marvel that pushed the boundaries of what was physically possible at the time. The DC-4E was a beast. It featured a triple vertical tail to fit into existing hangars, a massive nose wheel, the first of its kind on a large aircraft, and a pressurized cabin that allowed it to fly above the weather. It was the first modern giant. But as the prototype began its flight tests, the dream started to crumble. The aircraft was a victim of its own ambition. It was over-engineered and staggeringly complex. The triple tail design created massive drag. The hydraulic systems were a nightmare to maintain. Most importantly, it was heavy, far heavier than Douglas had promised. For the American Airlines, the DC-4E was a beautiful, expensive failure. It was too much airplane for 1938. United Airlines looked at the operating costs, looked at the maintenance logs, and walked away. Douglas was left standing on the tarmac with a multi-million-dollar paperweight that no one in America wanted to fly. But while the Americans saw a failure, the Japanese saw an opportunity. Through a front company called Great Japan Airlines, the Imperial Navy reached out to Douglas. They claimed they wanted the DC-4E for civilian long-distance routes. The U.S. government, surprisingly, didn't block the sale. At the time, they viewed the DC-4E as a commercial dead end. They figured if the Japanese wanted to waste their money on a rejected, overweight prototype, they should let them. It was a massive intelligence oversight. The Americans laughed as the crates were loaded onto the ship. They thought they were taking out the trash. What they didn't realize was that the Japanese weren't interested in the plane's ability to carry passengers in luxury. They didn't care about the sleeping berths or the kitchen. They wanted to rip the skin off that aircraft and study its bones. They wanted the secrets of the wing spar, the massive internal beam that allowed a plane of that size to stay in the air. They wanted the secrets of the tricycle landing gear and the high-output engines. To the Japanese military, the DC-4E was a textbook.
They were planning to take the DNA of this American reject and mutate it into the G5N Shinzan, a monstrous heavy bomber that would eventually be known by the Allied codename Liz. As the freighter disappeared over the horizon toward Japan, the era of the propeller was reaching its peak, and the race for the monstrous heavy bomber had officially begun. The Japanese had the bird in their hands, but they were about to find out that having the blueprints is one thing, understanding the science behind them is another entirely.
The crates arrived at the Nakajima Aircraft Company's factory under a shroud of absolute secrecy. Armed guards stood at every entrance. This wasn't just another project, it was a national priority. The Japanese engineers, many of whom had spent their lives designing small, light, maneuverable fighters, looked up at the DC-4E and felt a mix of awe and terror. It was a giant. To understand it, they didn't just need to fly it, they had to destroy it. The gentle giant was meticulously stripped. Every bolt, every hydraulic line, and every rivet was catalogued. But as the skin came off, the Japanese engineers hit their first wall: American metallurgy. The DC-4E was built using high-tensile aluminum alloys and specialized steel that Japan simply could not produce. The Americans were using flush riveting techniques that reduced drag to almost zero, a process that required precision machinery Japan hadn't imported yet. They realized they weren't just copying a plane, they were trying to replicate an industrial infrastructure they didn't possess. The order from the Navy was clear: take this airliner and turn it into a weapon. But a plane is not a Lego set. You cannot simply cut a hole in a passenger cabin and call it a bomb bay. The DC-4E was designed as a pressurized tube, a structural soda can meant to hold air in. To turn it into the G5N Shinzan, engineers had to gut the interior. They had to reinforce the floor to carry thousands of pounds of high explosives and cut massive doors into the belly. This destroyed the structural integrity of the original design. To fix it, they had to add more steel, more bracing, and more weight. The monstrous scale of the plane was quickly becoming its greatest curse. Then came the engines. The original American Pratt & Whitney engines were reliable, but the Japanese Navy demanded more power for their monstrous bomber. They decided to swap the American tech for 4 Nakajima Mamoru engines. On paper, the Mamoru was a beast, a 14-cylinder radial engine designed to produce nearly 1,900 horsepower. But the Mamoru was an experimental disaster. It was prone to overheating, and its cooling fans were notoriously unreliable. When they bolted these 4 monsters onto the wings of the Shinzan, the aircraft began to scream in a way it was never meant to. During the first engine tests, the vibration was so intense that it felt like an earthquake. The massive 14-foot propellers created harmonic resonances that traveled through the wing spars, causing the cockpit instruments to rattle so hard the pilots couldn't read their altitude or speed. It wasn't just a noise, it was a structural threat. The wings, already stressed by the extra weight of the added armor and turrets, began to develop microscopic fractures before the plane ever left the runway. The engineers were now caught in a weight gain spiral. To stop the vibration, they added more reinforcement. The reinforcement added more weight. To lift the extra weight, they needed more power, but more power meant more vibration. By the time the first G5N1 prototype was fully assembled, it was a Frankenstein's monster of American geometry and Japanese patchwork. It featured a glass nose for the bombardier, 2 massive dorsal turrets, and a tail gunner position that looked like it belonged on a battleship.
It looked terrifying. It looked like the ultimate weapon. But beneath the dark green paint, the plane was struggling just to support its own mass. The final insult to the engineering team was the landing gear. The DC-4E's tricycle landing gear was a revelation. It allowed for safer landings and better visibility. But Japan's runways were not ready for a 60,000-pound aircraft landing on 3 points. They had to redesign the entire shock absorption system using inferior rubber and steel. Every time the G5N touched the ground in testing, there was a very real fear that the nose wheel would simply snap off, sending the entire multi-million-yen project skidding into a fireball. As Act 2 closes, the G5N Shinzan stands on the tarmac, a dark, hulking shadow of the silver airliner it used to be. The Japanese had successfully cloned the American reject, but in doing so, they had created a plane that was too heavy to fly effectively, too vibrating to aim its guns, and too complex for its own mechanics to fix. The monstrous dream was about to meet the cold, hard reality of the sky.
The moment of truth arrived on a clear morning in 1941. As the 4 experimental Mamoru engines roared to life, the G5N Shinzan, the mountain recess, prepared for its maiden flight. The high command of the Imperial Japanese Navy watched from the edge of the runway, expecting to see a display of terrifying power. But as the plane accelerated, it didn't look like a predator. It looked like a wounded animal struggling to break free from the earth. When it finally lifted off, the disappointment among the engineers was immediate and gut-wrenching. The monstrous bomber was a failure. Despite its 4 massive engines and its stolen American DNA, the Shinzan was pathetically slow. It had a top speed that barely crossed 260 miles per hour, making it an easy target for almost any Allied fighter. But the speed wasn't the worst part. It was the useful load. Because the Japanese had been forced to use heavier, inferior materials to reinforce the airframe, the plane was so heavy that it couldn't carry a full load of bombs and enough fuel to reach its targets at the same time. It was a long-range bomber that couldn't go the distance and a heavy bomber that couldn't carry the weight. The Navy was furious. They had spent years and millions of yen chasing a ghost. Out of the 6 prototypes built, the results were always the same: engine failures, structural cracks, and a complete lack of performance. The project was so embarrassing that the Navy made a radical decision. They ordered the glass noses painted over, the heavy defensive turrets ripped out, and the bomb bays sealed shut. The world's most ambitious heavy bomber was demoted. It was turned into a Shinzan Kai, a glorified cargo transport. The king of the skies was now a flying truck, used to ferry spare parts and high-ranking officers safely behind the front lines, far away from the American fighters it was supposed to destroy. As the war progressed, the Allies began to pick up signals of a massive new Japanese aircraft. Intelligence officers gave it the codename Liz. They prepared for a monster, expecting to see formations of these 4-engine giants raining fire on Pacific bases. But the Liz never came. While American B-29 superfortresses were beginning to burn Japanese cities to the ground, the G5N sat in the shadows of hangars, grounded by a lack of spare parts and its own unreliable engines. The climax of this tragedy occurred in 1945. As American Marines and technical intelligence teams, the famous Operation Lusty units, began to sweep across captured Japanese airfields, they found something that stopped them in their tracks. In the corner of a bombed-out hangar at Atsugi, they found the rusted skeletal remains of a G5N. The American investigators walked up to the wreckage and realized they were looking at a ghost. They recognized the landing gear. They recognized the distinct sweep of the wing.
One of the officers reportedly remarked, "It looks like our old DC-4E, but it's gone through a nightmare." The Americans photographed the Liz from every angle, documenting how the Japanese had tried to mutate their rejected airliner. They found that the Japanese had even tried to simplify the design late in the war, moving back to a single tail, the exact same conclusion Douglas had reached years earlier. The wreckage was proof of a total technological defeat. Japan had tried to steal a shortcut to greatness, but because they lacked the industrial muscles to support the bones they stole, the project had literally collapsed under its own weight. But the final irony is the most stinging of all. While Japan was failing to clone the DC-4E, the American Douglas Aircraft Company back in America had taken the lessons from that very same billion-dollar reject. They stripped away the triple tail, simplified the internal systems, and lightened the frame. They turned the failed DC-4E into the legendary DC-4 and its military version, the C-54 Skymaster. While the Japanese Liz was rotting in the rain, the American C-54 was becoming one of the most important aircraft in human history. It was the plane that won the logistics war in the Pacific. It was the plane that later saved the city of Berlin during the 1948 airlift, carrying tons of food and coal to a starving population. The Americans had used their failure to build a masterpiece of peace, while the Japanese used that same failure to build a monster that couldn't even bite. The story of the G5N Shinzan remains a haunting chapter in aviation history. It is a reminder that in the world of high-stakes engineering, you cannot simply buy your way to the top. Japan bought the trash, but America kept the treasure. The worst heavy bomber in history didn't end the war, it ended an era of arrogance, proving that a plane is only as good as the nation that builds it.